So here's an example of polar covalent bonds in water, right? So hydrogen, the hydrogens have one electron to share. Water or oxygen needs two electrons, so it bonds with two hydrogens to form H2O or water, right? But because the oxygen has 8 protons, then the electrons that are being shared go around the oxygen more frequently than they do the hydrogen. So what happens is that the end with the oxygen, the red part, becomes negatively charged because the shared electrons are going around them more frequent, around the oxygen more frequently, and that end of the molecule. If you look at the hydrogen, those areas just have one proton, and the electrons don't go around them very often, so both of the hydrogens, the blue portion of the molecule, are going to have a slight positive charge. So when they hook together, those you have a positive charged area and a negative charged area. So those different poles of the molecule will be attracted to other polar molecules, right? And those portions of the molecule will be attached together because of differing electromagnetic charges. And when that happens, we form hydrogen bonds, right? Hydrogen bonds are weak bonds formed between a hydrogen atom of one polar molecule and the negatively charged end of another polar molecule. A good example here is ammonia, right? We'll talk about that here in a second. But hydrogen bonds are really important because they're more easily broken than the covalent bonds, but they provide structure for certain molecules, especially DNA. DNA structure is held together. DNA structure is, there's two strands that are kind of twisted in a spiraling staircase structure, right? And those two strands are held together because of these hydrogen bonds. Water makes droplets because of hydrogen bonds, all right? So hydrogen bonds are really important, so in the diagram you can see that the red being the this is water, but if you take the positive ends, which are the protons, and they would be connecting to the red ends of the oxygen, so they just stick together to form large amounts of water, right? A droplet or a gallon of water or whatever. They're all just these single polar molecules that are held together by these hydrogen bonds to form the amount of water that you need, right? So water is polar, ammonia is polar, and when you put water and ammonia together, and I would not do this in a closed environment because it could cause some serious problems, but when you put ammonia and water together, they readily mix together, right? They blend together because they're both polar. If you were to try to put a non-polar molecule into water, which is polar, they do not mix at all. For instance, vegetable oil. If you were to put vegetable oil in water, you get a glob, right? You can stir that glob and make it into smaller globs, but they still do not dissolve into water. So non-polar molecules and polar molecules don't mix, right?